Checking every sensor in your building is impractical. However, there are 5 major energy-consuming items of equipment. They are the air handler, your boiler, your chillers, your cooling towers, and your pumps. You need to make sure that these items of equipment are on your maintenance schedule so that you can check them periodically to reduce your energy consumption. This is your cooling coil temperature sensor, which is normally inserted in the duct airstream. To measure and verify that this sensor is sending the right readings to the BMS, I would use this hot wire anemometer and insert it in the stream to ensure that the proper signal is being sent to the BMS. This type of anemometer measures wet bulb temperature as well as dew point, which is good if you don't have an economizer with enthalpy control. If you were going to measure duct static pressure, you would need a different tool. So just reach out to your lending library and let them know exactly what you need. This is an outside air temperature and humidity sensor. We take advantage of outside air whenever possible. This sensor is vital to your system and should be checked regularly to ensure it's calibrated. If it's not calibrated, it could cause you to mechanically cool or heat when unnecessary, or it may cause you to miss an opportunity to engage in free cooling when the outside air temperature matches the set point of the space to be conditioned. This sensor is also used for controlling other systems such as hot water resets, chill water resets, boilers, and perimeter radiated systems. Checking the outside air temperature and humidity sensor is most important when it comes to energy conservation. You also want to make sure the sensor is out of direct sunlight and protected from the rain so that it doesn't give you a false reading. The most important sensor on your system is your freeze stat located here, which protects your cooling coil from freeze up. If your temperature drops below about 37 degrees, the freeze stat will shut the system down and cause the heating coil to fail in the open position, protecting your cooling coil. Another important sensor is the mixed air temperature sensor. This is typically an averaging sensor located inside the mixed air temperature chamber. Because it tells the system how much mechanical heating or cooling is required, it's typically installed so that it covers the full length of your chamber. Outside air, return air, and mixed air dampers, as well as smoke dampers, all have actuators. Valve controls for heating and cooling also have actuators. You need to check these to make sure that they're properly working and connected properly to ensure that they're providing the proper percentage of action. For example, is it commanded 10% open or 90% open? Typical safeties in your control system include your freeze stat, high pressure cutout, and sometimes leak detectors. You need to be aware of these and make sure they're working properly to protect your equipment and property. You also need to check your proofs. A proof is a device that proves that an item of equipment is doing what the BAS says it's doing. For example, if you're trending a fan, you want to make sure that that fan is actually running and at the speed indicated on the BAS.
What I have here is a control sequence of operation for an air handler, also known as a CSO. What the control sequence of operation indicates is the different modes of operation, which can be seen here on the actual BMS. The static pressure control sequence, as indicated here, would take your set point. It also has a sensor, which tells you is the system responding to the set point, which in turn gives us an indication of the feedback of the VFD. So is the VFD responding properly to our static pressure set point? It also indicates safety operations, which would be a freeze stat. So if there was a low limit alarm, you would get an indication here. It would also stop the unit from running. It would also indicate high and low pressure across the fan. So if there was a condition of a high or low pressure, the fan would stop, and this would indicate an alarm here. Also, the sequence indicates proof, which would be, is the unit physically running? And that is indicated by your VFD feedback, as well as your static pressure, as well as the small fan diagram physically running. So that is all considered proof that this unit is indeed running.